Welcome back. Time for chapter 12. I was about to do this and then I was like, that's just weird. So back to chapter 12. Um, Hopefully it's working out for you. I know it's so busy behind me, but I figure most of the time you're just looking at the PowerPoint anyway, so it's not that big a deal. All righty. Let's get this to slideshow. There we go. Slideshow. Chapter 12, food, water safety, and food technology. Lots of good stuff here. When shopping, do you gravitate towards fruits and vegetables that are organic, even if they look slightly less appealing, or those that have been treated with chemicals because they look better? So, do you shop for appearance? Most people do, just so you know. Why would you choose one over the other? Again, most people shop by appearance. You see something that looks big and plump when you're looking at like the meat, or you see the fruit that is nice and big and solid looking, or you see the one that looks slightly discolored. Most people are going to go for the other one. That's why there's a whole company called Misfit Food, I think. um they actually give you all the ones that look ugly, but they're still perfectly good. But anyway, this whole thing's all about this stuff. It's a learning objectives, blah blah blah. Microbes and food safety. I'm pretty sure everybody here knows that there's a lot of foodborne illnesses. There are recalls all the flipping time on the news and posted everywhere. Sorry, I just got distracted by my kitty Osiris. He's peeking out at me. There's a whole lot of reasons why there's constantly recalls and there's different foodborne illness. Sorry, foot just did a thing. Illnesses, and we're going to cover a bunch of those. Some of them are going to be microbial. Some of them are going to be natural toxins. Some of them's residues. That kind of stuff. So here we go. Foodborne illness caused by microorganisms, microbes, and pathogens. Just going to bring them around. Infection like salmonella bacteria or the hepatitis virus. And then caused by intoxication, enterotoxins and neurotoxins. And so those are going to be like these different various bacteria type things. And a lot of these are life-threatening for certain people. So this is just letting you know what to look out for. I think just about everybody has gotten some kind of foodborne illness at some point in their life. Sometimes it was food poisoning. Sometimes you're just like puking for a few days and then you feel better. Other times it's just your gut clenches. We used to call it the bubble guts. And the issue is sometimes it can be life threatening. And so where it says warning signs of botulism is a medical emergency. So if you're having a hard time swallowing or breathing or double vision or weak muscles, that kind of thing, you need to go to the ER like immediately. Food safety, how it's supposed to be. The farm is supposed to be particularly safe. Then the processing is supposed to be particularly safe. That's why we've got the FDA, and they're supposed to keep an eye on it and make sure that everything follows particular rules. Then we've got the transportation. If something is supposed to be kept cool, it needs to be shipped cool. Putting it in a non-insulated or a non-refrigerated truck sometimes can cause major issues. And so the containers and the vehicles transporting it are supposed to follow very particular rules. Retail, where you're buying your food, there are all these different codes that they're supposed to follow as well. And they're supposed to be checked randomly to make sure it's all safe. Actually, all of these are supposed to be checked randomly to make sure they're safe. And then to your plate, you also have your own safety protocols that you need to pay attention to. And no one's going to come in and police your kitchen to make sure you're following proper protocols, but there are very personal ones that you are in charge of to help keep you and your family safe. So we have different ways that the outbreaks may occur, and different things here are listed about how we're supposed to try to control them. I'm going to wait for a slide a little bit later, and then I'm going to go over some of the way a lot of these outbreaks happen. Just know that we're supposed to have in place government stuff to keep an eye on things, to make sure things are done very particular. And they also are supposed to randomly like spot check, like go to random grocery stores and take stuff straight out of there and test them. because you can't test everything. So it's done by a sampling. And then you also have here consumer safety at the grocery, how to know what dates on packaging means. A lot of us don't have a whole lot of money, and so we tend to get the stuff that's on sale. And you will see a lot of them say best by date. And best by means that that is best by that particular date. Some things it's still safe to eat after that date. Others, maybe not as much. So you need to really look whether it says best by or expired. Those are two totally different things. And we have a tendency to not pay attention to that because we just see a date. Make sure to look for best by versus expired. I think you know what expired means. Food provides ideal conditions. We need all the proper nutrients and moisture. And I'm sorry, food provides the ideal conditions for the pathogens and the bacteria and the stuff that's not great. And that would be the nutrients and the moisture and the temperature. As soon as you take something out of the refrigerator and it gets nice and toasty, bacteria is reproducing like crazy. It's like having a blast. This is why if you've ever seen stuff where it says do not refreeze, it's because as soon as you thawed it out, everything started to reproduce. And when you refreeze it, you're refreezing all of that extra bacteria. Then you're thawing it out again, and then it goes nuts again. This is why if you've ever had something that you've taken out, put back in, taken out, it starts to look almost poofed up. That's from the excess bacteria. Something that's not canned properly and you open it, normally that's, the bacteria. Also, if you're buying, I'm going to say like frozen peas, because that's a really good example, because those should all be individually frozen. You go to the grocery store and the inside of it feels like a block. And so you're like, when you're mashing it up, trying to break them all up, it's better to just not get that one, because if it's in a block like that, that means it had thawed out enough and then refrozen, which means you have more bacteria in that bag. So anytime it is between 40 degrees and 140 degrees Fahrenheit, that is the absolute perfect condition for the bacteria to proliferate. Best ways to defeat the bacteria: clean, separate, chill, cook. You need to make sure everything's clean, your hands, the surface of everything, even your kitchen towel. Every time you wash your hands and then dry it on that kitchen towel, you have contaminated that kitchen towel. You do it multiple times throughout a meal. Anytime you didn't wash your hands and rinse them enough, you might have already spread the bacteria there. There's this really cool lab that I'm hoping we can do in Bio 123 next time, where we show how fast the germs spread. And if we have the stuff, I would totally just do it in this class too, just for fun. Separate. Keep your raw foods away from the ready to eat foods, because the raw foods don't have anything keeping the bacteria at bay. The ready to eat, hopefully you have already done something to remove the bacteria, whether it's, you've already cooked it or it's been processed in some way to help bring it down. Cook. Proper temperatures to kill this bacteria. And then chill, refrigerate it promptly and keep it cold. If the food is supposed to be cold, keep it cold. If you have ever left a glass of milk out on the table while you're doing other stuff, that gets bad really fast. Dairy goes bad very quickly. So, proper washing. You wet your hands with the clean running water. It says turn off the tap because we're trying not to waste water. Soap. Lather. You should be doing this for a while. And it's not just this. It's in between your fingers and then under your nails. You do this, and then I do this, so I get my knuckles too. And then you scrub it, and you do it underneath the water to rinse. You don't just, you're also doing all this to get all of the rest off. And then you dry your hands. That's how you properly wash your hands. A lot of people do just a quick like this, or the one that really drives me crazy, they just under the sink. Do it all proper. There you go. Clean, separate, cook, and chill. Separate. We already said that. Keep your raw food away from the ready to eat foods, because there is such a thing as cross contamination. You can have something that has some kind of bacteria that can go from one to the next. You've heard about the importance if you're cooking chicken, use a different thing, flip the cutting board, do whatever. Quite frankly, you should not just flip the cutting board. You should use a completely different one because flipping it, now you're just putting all the other stuff directly underneath it. Wiping it on the towel, you have just now contaminated the towel, that kind of stuff. You should really separate, take the time to do it. And chicken is not the only thing that has the bacteria that can spread. That's just the one for the salmonella, which, by the way, is in things other than just chicken, just so you know. Cook proper temperatures. When you look at the directions on something and it tells you a certain temperature, there's a reason. And normally it's to make sure that the internal temperature gets high enough to completely kill everything that's in it. Hold at 140 degrees or higher. So once something is already cooked, and please note on the little thing on the side, it says reheat pre-cooked ham. A lot of people will get that ham and then just sit there and munch on it. When it's just sitting there on the table, it's growing, possibly growing more, or not growing, but producing more bacteria. It starts to go downhill. Now, it is insanely high in salt in order to try to help preserve it for longer. But we talked the last chapter about why you don't want to have stuff really high in salt either. But anyway, if you have cooked stuff and you have it sitting out because you can't get to it yet, it's supposed to be kept at 140 degrees or higher in order to keep, again, the bacteria at bay. And then to chill it, it's supposed to be 40 degrees or lower for the same reason, to keep the bacteria at bay. Because in between those two things, man, that's where the stuff goes crazy and proliferates like crazy. All right, we are now going to match these up. Again, if we were in person, we would be doing it that way, but I'm going to do it this way. So the proper internal temperature to kill microbes, you cook it. That's how you get the proper internal temperature. Soap and warm water, that's cleaning. Place in the refrigerator or freezer promptly. Of course, that's chilling. Raw eggs, meat, poultry from other foods. So you're separating all that. Wash hands and surfaces. That's clean. And cross-contamination means separate because you don't want to get the ick from this onto that. Which foods are most likely to cause illness? How many of you know what it's going to be? There you go. Meat. Most of your meats. Ground meat, stuffed poultry, raw and undercooked eggs, seafood, raw milk products. There's a few reasons for this. I was trying to decide which one to be on to talk about this. Okay, so I'm going to start with the raw milk products. Raw milk products often contain various bacterias just from the nature of the beast, where it's coming from the udder and from the diet of the cattle. If the cattle is not healthy, are not healthy, cattle is plural. If the cattle are not healthy, or if the individual cow has an issue or a virus or something, this can affect what's in the milk itself. Like currently, they have done spot checks of some of the milk in grocery stores that have actually already been processed. So this is not the raw milk. This is actual go buy a jug of milk from the grocery store. They're finding traces of the current avian flu, the bird flu, in some of the milk in grocery stores. And that's showing that the avian flu is affecting, like already, it has already spilled over into mammals. It's not just a bird flu anymore. And a lot of our cattle are getting infected, and this is showing up in the milk. That's in our processed milk. So if you had the raw milk, it would have way more because the process of what they're doing to the milk to put in the grocery store is supposed to get rid of most of those things. If it's raw, it's going to have even more. Seafood, water quality is a thing. A lot of the stuff is just not healthy. You have various things growing in it. A lot of the farm raised seafood, it's not the healthiest condition. And too many in too small an area because they're not thinking about it as actual living beings. They're just seeing it as a harvest. And so they put too many in too small an area, then one of them gets sick and it spreads to everybody. Raw and undercooked eggs. And yes, I'm going from the bottom up for a reason. Eggs may or may not have salmonella depending on the chicken. And so that can spread. And you can't test every single egg, you know? Stuffed poultry, it's not even just stuffed poultry, it's poultry in general, because again, we know that chicken can have salmonella. But chicken and meat, ground meat and regular meat, but ground meat specifically because of the surface area, which I'll get to in a second, the meat industry. If you have never watched a special on how your meat came to be your meat when it used to be an animal, that's a very important thing. Most of these processing plants basically just take them, slice them, move them on. They are not very clean. If you look at the ingredients list, there are things on there that will say things like mechanically separated chicken. That means it's just machines throwing this stuff everywhere. And the slaughter process normally cuts the suckers open. We have E. coli living inside our gut. That's part of the digestive system. That's part of what breaks things down. So when they slice open a cow or a pig and move it along, it's going to be entrails. It's going to be poop everywhere, which contains the bacteria, and it splashes. It's not nice and neat. You have this stuff going everywhere, and it can get onto your meat. How many people wash their meat before they eat it? Like, really, most people don't, because you're like, well, it's meat. They've taken care of it. You don't know what's on that. It's nasty. Then you have ground meats. Ground meats are even worse, because when you have one entire like steak or a chicken breast or a whole turkey leg or something, the outer part contains the most bacteria. So as long as you're cooking it, you're killing all the bacteria. Once you grind it up, every little thing, I don't know what to call those little beads of tissue that you're eating when you grind up the meat, but those little things, bacteria all around every one of those, then you know, make your patty or whatever and you cook it. You have just put all that bacteria inside it as well. So if you don't cook it all the way through to the proper temperature, like they're showing here, you have all this bacteria building on the inside. So ground meats are one of the unhealthiest, most likely to get you sick because of how much bacteria it holds. Now, raw seafood myths and truths. I thought this was funny. I had never heard any of these myths. Raw seafood can make you sick no matter what, period. It doesn't matter if you ate it before or not. Every time you have a new piece, it's a brand new thing. And a lot of this, it's going to talk about the oysters, because a lot of people, for some reason, like raw oysters. I don't understand, but whatever. There are so many issues at the, does this one? No, later it's going to talk about the red tide, because that's something. But yeah, hot sauce is flavor. It's not going to destroy anything. Alcohol is not going to destroy it. If you soak it in alcohol, sure, but drinking alcohol with it, no, that's not going to kill the germs. And each batch of seafood has its own stuff. So just because you had it once and you had no issue doesn't mean you're never going to have an issue. Raw produce and other foods. Pasteurized, that's what the word I was looking for when I was talking about the processing of the milk. Any kind of raw produce means raw. It means there might be stuff on it. Unpasteurized juices, that means it has not gone through the system in order to kill the pathogens. Unpasteurized means they have not pasteurized. Pasteurizing is destroying the pathogens. That's how it all goes together. Sprouts. I'm not going to lie, I love some good sprouts. I really, really do. But you have to make sure they're seriously clean, because sprouts hold on to a lot of stuff. Even honey, raw honey, that can contain pathogens. That's why most things we do have processed. Picnics and lunch bags. Yeah, I am a big proponent of bringing your food, but that's also why I have an ice pack in there, because if you pack something and you're not keeping it cold enough, then it's building bacteria that entire time. That's why refrigerators, coolers, ice packs, that kind of thing. And then takeout foods and leftovers. Oh goodness, the number of things, just go ahead and Google it. It's fascinating and terrifying. The number of people who get sick and die from leftovers. They'll get like noodles from a place and then leave it on the counter because they're at a hotel and they don't have a microwave and they don't want it cold. And then they come back to it a couple of hours later and then they're shocked when they get sick. Dude, when you have it just sitting out for a few hours, it's just bacteria building, 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 building. If you're not going to go over there and just decide to eat a spoonful of bacteria, then you need to properly put away your food. So, irradiation benefits. This helps control a whole bunch of stuff. Modified atmosphere packaging. This is where they're trying to package things a very particular way, like, wrapped in the plastic. Various things in order to try to control what goes in and what comes out. Toxins, residues, and contaminants in foods and water. Natural toxins. I found this one fascinating. Before doing this, I was like going through the whole PowerPoint and checking it, and I learned a few things from this slide alone, and I thought that was pretty cool. Like, one, I did not know sassafras was toxic. No idea. I'm wondering if that's how come it went from having sarsaparilla, which used sassafras, to having root beer, where they used something different. I think that's interesting. Now, the cabbage family. I did not know that raw cabbage, turnips, mustard greens, and radishes all contain a small amount of this toxin that can interfere with the thyroid hormone production and can enlarge the thyroid gland. That doesn't mean they're bad for you. It just means small amounts, because cabbage, turnips, mustard greens, and radishes all contain so many good things for you, but that just means don't eat too many. And I'm very grateful to have read this because, oh my gosh, I love radishes. I can just snack on raw radishes. Foods with cyanogens. Cyanogen is a precursor to the deadly poison cyanide. And look at this right here. Whoa, I was trying to highlight it right here. Cassava. I did not know that cassava was in this family. And so most cassava is very low in this. But that means you really should be careful how much cassava you're consuming. And I know there's a lot of people, it's a staple. And so a lot of people eat it every single day. You might want to try to, not do mass quantities. Apricot and cherry pits also have this, and they tend to be used as a cancer cure, but it's not. There is no cancer cure. And I do want to definitely mention that, because there are so many things marketed. This will cure cancer. You take this and you've reduced your risk of cancer. You reduce your risk of cancer by being healthier and eating healthier things, not by popping a pill, just so you know. I liked this where it said, this poison kills cancer cells, but only at doses that can kill the person too. Dude, if you're killing yourself, yeah, you're not going to die of cancer. So be careful. Oh, here's the red tide toxin. Occasionally we have red tide, and then that will end up completely poisoning the seafood there, any of the filter feeders and stuff. So like all the shellfish becomes poisonous. And so if you consume shellfish, keeping track of whether or not there's been a red tide and where your seafood is coming from is extremely important. Pesticides, we all know about pesticides. Benefits versus risks. Benefits, it helps keep the pests at bay. Risks, some people are allergic. It can kill some people and it sticks as a residue. It doesn't just wipe off. So anyone who grabs the apple and goes, you haven't removed crap. Like, you might have just smeared some stuff on your shirt. That's pretty much it. You need to actually properly wash your stuff. Regulation, there is no actual reference dose. Yeah, pesticide. And then we have natural ones where we have organic gardens, and it says persistent. So organic gardens, legally to be listed as organic, you have to have less than a certain percent. It does not mean none, unless the company specifically states none, and you have researched into the company and seen that that's actually true. There are natural ways to do it. And so a lot of, and I talk about this in environmental science, a lot of these will use like natural predators, like ladybugs and stuff like that. So there's never poison sprayed on your food. But any kind of pesticide, it's basically a type of poison being sprayed on your food, and it doesn't just disappear. The more nooks and crannies, the more it's going to hold. Like strawberries, as wonderful as they are, hold a lot of pesticides. And so you should really make an effort to properly clean those, which, by the way, anyone who's ever watched the TikTok or stupid videos where like, oh, have you ever noticed? Take these strawberries and put them in this water, and then they come back and you see these things swimming around. That's a load of crap. That's no. Please use your logic skills and your critical thinking skills. Nothing that big is coming out of the flipping strawberry unless you saw a hole in the strawberry to house it. But you do need to properly wash your strawberries due to the amount of pesticides it can hold. I really wanted to make sure you saw this top part. Trim the fat from meat and remove the skin from poultry and fish. Discard fats and oils in broths and pan drippings. That means anytime you're holding on to the fat in the pan and you make a gravy, that is upping your chance at getting sicker, because the animals hold the pesticides in their fat just like you do. And the juices that are coming from your meat are from the blood and from the fat. And that's where all the pesticides are going to be. So you should not be holding on to any of that. Yeah. The rest of this is reminding you, wash, don't just rinse, wash, rub it, rinse it thoroughly, peel if you can. Here where it says use a knife to peel an orange or grapefruit, the reason it's saying that is because if you're peeling it with your hand, you've never scrubbed it. You're peeling it with your hand and then you eat it, you have just gotten the pesticide all over your hands and then ate it. That's why they specify this. You can wash them, so then you can do it any way you wish, but it takes a lot of effort to wash it. Anything that is wax is going to strap it in there. You just have to remove all the wax. You have to cut it all off and then wash the rest, because wax holds it, period. Any peelable produce, if you're trying to get rid of the pesticide and you don't want to do a good soak and scrub and wash method, just peel it. But the sad thing is, a lot of times the peeling, like for the carrot and the apple, you're losing a lot of the nutrients by doing that. It's better to be able to have the peel, but due to using pesticides, you might not have the choice. So if you have a choice to do organic, that's a healthier one, a less likely to be consuming the pesticides. Okay, then we have our animal drugs. We know about the overuse of antibiotics in the feed industry. Then we also have the bovine growth hormone. This is where they're pumping this stuff into the cattle to make them grow bigger faster, to make more money faster. And then arsenic. Yeah, that's poison. These things are in your animals on a regular basis. Like if you're eating animal, this is in them. Then we have the environmental contaminants. The bioaccumulation is part of why I keep going on and on and on about the importance of getting rid of all the pesticides, because bioaccumulation means it just keeps adding. Bio for life, accumulate, building. So it keeps building higher and higher until it gets toxic. Heavy metals. I have no doubt you have heard about various heavy metals, and I'm not talking about bands. I'm talking about the metals that are not good for your body. Environmental science, I love to point out the dangers of fireworks due to the heavy metals and what it's throwing out into everything and then coming down and then landing into our water. And we're like, oh, ooh, pretty. Oh, hey, guess what I just added to my drinking water? But anyway, mercury is a big one. That's the one that we have covered in Bio 1, 2, 3 and in environmental science, if you have that. And we have a slide that we're going to talk about that in just a second. And then PCBs, you've seen that on stuff, and other chemicals. So accumulation of toxins. This is the bioaccumulation. What happens here is we've got I'm going to use mercury as an example. We've got the coal plants, we've got the different productions where it's throwing the methyl mercury up into the air, and it's like, dun, 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 dun. It rains, it comes down, it gets into the water, gets into the ocean, and then the phytoplankton munch on it. And then the little fishies, the little guys, eat a whole bunch of the phytoplankton. And then the slightly bigger fish eat those smaller fish. And we go up and up and up and up and up until finally we get where somebody is catching the big fish. And here it says like lake trout, walleye, and bass. You can go even bigger than this when you start talking about things like tuna and swordfish. You get to the ocean. This is more like a lake here. And then the person eats it. Look at the red dots here, and it's showing you how much more there is in each one because of how much was in what was smaller. This is what is bioaccumulation. It's getting to be more and more the farther up the food chain you go. And so then when we eat something that's way up high, we are getting so much more. And mercury is one of the main ones. And this is why I've said in class before that if you take a look at a can of tuna fish, it actually has a warning for pregnant women, which is scary. So discuss mercury levels in seafood and why it is important to minimize your consumption of mercury. We just did that. This was that whole, see right there, the methyl mercury. Methyl mercury concentrates in the flesh of large predatory species of fish. Cooking and processing does not get rid of the mercury because it is literally in the tissue. If you're eating fish, you are consuming mercury, period. And mercury is really bad as it builds up because it destroys things. It sits here and says damages living tissues, developing brain, pregnant women, lactating women, children are the most vulnerable to mercury toxicity. I'm going to tell you, and I've done this in other classes before, if you ever heard the phrase mad as a hatter, it came because of mercury poisoning. Because the hatters used to have their pins dipped in mercury in order to slide through the fabric easier. They would hold the pins in their mouth while they're doing stuff so they can, and it made them go crazy because the mercury literally is eating holes in the brain. So it's bad. This is why you need to be careful about how much you're consuming. And the larger the fish, the higher the level because of bioaccumulation. So if you are eating a lot of these large fish, you are getting more mercury into your body. Now we've got water safety and sources. Only about 1% of the water on the planet is potable, which is usable. And this comes from surface water and groundwater. Groundwater, we are destroying every time we're just dumping stuff into the ground. Anytime somebody pours gasoline on an anthill, you have now added gasoline into the groundwater. Every time a field is sprayed with pesticide, we have added pesticide to the groundwater. Yeah, that's what's in our water. Safety of tap water. You can look up the water quality of where you live and see the testing that's being done so you can have an idea of the quality of your tap water. Most places add chlorination to the water in order to help, make it safer. A lot of people say, well, that's why I only drink bottled water. Well, guess what? It's not any safer or healthier. Take a look at where it all comes from. You also don't know how hot or cold it's been kept. If it has gotten too cold and then warmed up, or if it's gotten too hot and then chilled down, that is leaching plastic into the water that you're drinking. And that is where you're getting a lot of your microplastics. Bottled water is actually typically less healthy for you. Getting something to filter your water and then a reusable water bottle, like my best friend over here, you control more of what's going into you. Every time you crack open that plastic bottle of water, you are introducing more microplastics into your body. So, water has been in the news a lot lately, from lead in the water to potentially harmful effects of bottled water. I'm skipping to here because this is your in-class assignment 12. Do you prefer tap or bottled water? I want you to answer that. Which one do you tend to drink? And then can you taste the difference in water in one area? Like, can you tell the difference of the water we get on campus from your house? Or if you've ever been somewhere with a well, can you tell the difference in taste? And then explain what you mean. And do not just say, oh, it just tastes bad. I want more than that. Go in depth. And then tell me which type of water you tend to drink and if that's going to be the water you're going to keep drinking. Now that you learned that bottled water tends to be higher in the microplastics. Food additives. All right, FDA requirements. Manufacturer has to prove that the additive is effective, like not that they're putting it in there just to be putting it in there. There has to be a reason and how much and whether or not it's safe. Whoa. Antimicrobial agents and antioxidants, those are good things. There is nothing wrong really with having those in there. It's there to help protect the food. This is to help keep things safe or extend the life of. So learning what these are is helpful. And I say that because I've had people like, oh, it's got acetic acid. That's just vinegar, dude. Chill. Some people freak out over words just because they don't know what they are. So I would like you to take a look at these to get an idea. Artificial colors. Seriously, there is zero need for this. This is because we eat with our eyes. We want it to look a certain way, and that's why they add the color. There is no reason for this other than appearance. But some places are trying to do better. And so some of the things, when you read it and it says artificial colors, and then in parentheses, it'll say from vegetable sources. Keep an eye on that because, like, my mom was allergic to beets. I say was because I think she might have gotten out of it, but I'm not 100% sure. Kind of like I grew out of my allergy of tomatoes. Beet is one of the most common artificial colors. And so if somebody has a beet allergy, if it says artificial colors from natural sources or artificial colors from vegetables, you might want to contact them and make sure that you know what was used for these colors. But then they also have synthetic dyes. There again, no reason. Artificial flavors and flavor enhancers. I had this issue with artificial flavors. If I'm buying a food, why do you have to add a fake flavor to it? I don't understand, but they do it. The artificial banana flavor is a big one. And then they have things with the different nutrients or different nutritive sweeteners, the ones that don't have any nutrient there. It's just to make it taste a certain way. And then MSG, salt, spices, and sugars. Some of these are to enhance a flavor. Some are totally fake. Now, MSG, monosodium glutamate, this one gets a bad rap. There's a lot of people out there who like, oh no, I'm blah, 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 blah. You need to learn what it actually is. Not saying some people don't have issues with it, but I'm going to explain why it happens sometimes. So MSG used to come from a seaweed broth. It was a whole process. It came from seaweed. So if you had an iodine allergy, seaweed tends to be higher in iodine, you could have gotten a reaction. But typically, you're not going to have something from that. But a lot of times, foods that had the MSG in it also had other things, kind of like the gluten issue. Now, MSG tends to come from the fermentation of starch, sugar beets, sugar cane, or molasses. So if somebody is allergic to beets and like sugar beets and stuff, they might get a reaction. So it is possible to be allergic or sensitive to MSG, but it's not because MSG is a crazy chemical. That's one of those things that I like to clarify. So, all right. Now we've got our bleaching agents. We don't need those. There is zero reason for bleaching out our food. It's just taking away nutrients. Then we have this other preservative where it prevents discoloration and stuff. So citric acid, that's the main one that you will see on the list. There's nothing really wrong with this. It's naturally occurring. It helps preserve something a little bit longer. Nutrient additives. This is where they're adding stuff. It might say enriched. This is in order to try to make something a little healthier for you, have a little extra for you. And then stabilizing and thickening agents. It's right there in the name. And examples are right here: dextrins, pectins, starch. So if you see any of these on there, this is to stabilize or thicken. And I'm specifying this because you really do need to make sure to understand what some of the words mean, because there's a whole cluster of people out there who will take a word and then try to tell you how bad it is for you without understanding what it actually is. Pros and cons of bioengineered foods. Covered this also in Bio 123 when we talked about bioengineering. So the bioengineered food means that it's been worked on. It's not naturally occurring. And there's good and bad. So this uses recombinant DNA technology, which means it is recombining multiple forms of DNA. It's putting it together. It also includes selective breeding. So the example I normally use for this, and I wish I'd thought to find that slide because I always forget one of the things, but it shows that Brussels sprouts are not naturally occurring. That's one of the things that we tweaked. And same thing actually with broccoli, my love. And even lemons. Lemons are not naturally occurring. They naturally come from trees and other plants now, but it's because of very selective breeding. We sat there and kept breeding and tweaking it until it produced exactly what we wanted. Then we have the more obvious ones where it says here positive outcomes. Golden rice, I talked about that before. It is where they introduced vitamin A into rice because there were areas that were vitamin A deficient, but their main staple of their diet was rice. And so by making golden rice, they were able to continue growing rice that now had higher levels of vitamin A. So it was a way to get vitamin A into an area. Mass production of insulin and renin. Oh yeah, this is where most of our insulin comes from now, is from bioengineering. Greater crop yields. People who sit there and argue for pesticides because we need more food and then go against, like, oh no, GMOs are bad. That is so counter. I don't understand. You can't argue that one that is poisoning you is good because we need food, but one that does not poison you, we don't need because it's quote unquote not natural, while drinking a Coke and going to McDonald's. But anyway, greater crop yields is one of the things they've been able to do, where they have spliced it to where they now produce more. And then faster growing fish. That's supposed to be a positive outcome. I have issues with that. But there you go. Concerns: overdoses of nutrients and phytochemicals, accidental ingestion of drugs, pesticide residues. The pesticide residues, I think they're talking more about like the BT corn, where they spliced in there so it has its natural pesticide, but it's not actually a poison for us. But I am a little hesitant myself, not gonna lie. Environmental effects, outcrossing and wildlife. So basically the concern is creating an organism, whether plant or animal, and then it getting out and reproducing with something else and it messing everything up. So think of the fast growing fish that were mentioned on the last slide. If those fish get out into the natural world and reproduce with the non-modified fish, it's going to cross contaminate basically. And then ethical arguments like, is it okay? I think absolutely each one will have to be looked at individually. You cannot make a blanket statement about GMOs, because if you try to make a blanket statement about GMOs, you are showing how uneducated you are. Because again, our insulin for all of those people who have diabetes, which we've talked about in the previous presentation, are helped due to the GMOs. So you can't just do a blanket statement. All right, so that is the very end of this. Hopefully you learned something about it. And I cannot wait to be back in class. And I guess this will be my yet another. Make sure you have all your energy budget stuff collected, all of your food, the nutrient information, and the calories, and your activities. I need you to have a minimum of 3 days. I would rather a whole week, but a minimum of 3 days, because we need it. Make sure to get that done. Have it with you. Write it down, because assuming I get my okay to come back to class, I plan on talking about that on Monday, because I've been really looking forward to it. And hopefully all's good. Feel free to shoot me a message if you want, and peace.